that you have those memorized. We also are going to use Pythagorean identities. So the Pythagorean identities are sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. Now, whenever we do this, like if you go ask my calculus kids, they can probably tell you that sine squared theta plus cosine squared theta equals 1. They probably remember that from this class, or at least most of them probably do. They probably do not remember these next two right here. But let me show you something kind of neat about this. Those two are not really different identities. So if I have sine squared theta plus cosine squared theta plus 1, that one you definitely have to have memorized. If I go through and I divide, why is my pen not working like it's supposed to? There we go. If I divide by cosine squared theta, if I divide this whole thing by cosine squared theta, right here. Also, it is important for you to know the square. Whenever you're talking about a fraction, I already know that tangent of theta equals sine theta over cosine of theta. If I square both sides of that equation, I get tangent squared theta equals sine squared theta over cosine squared theta. So our reciprocal identities and our quotient identities, we can use those even if we have squares or cubes or something to the fourth power. So sine squared theta over cosine squared theta is going to give you tangent squared theta, right? Sine over cosine is tangent. Cosine squared theta divided by cosine squared theta, what's that? 1. That's this right here. 1 over cosine squared theta, 1 over cosine is secant. So that's secant squared theta, right? So it is not really a different identity. It's just a different presentation of that identity. It does not technically matter whether you do tangent squared theta plus 1 or 1 plus tangent squared theta. They're equivalent to each other. But the reason the 1 is second here, but it's first over here, is because they're deriving it from this equation right here. So you could do the same thing to get the last one. If I start with sine squared theta plus cosine squared theta equals 1. If you divide everything by sine squared theta right here, sine squared divided by sine squared is 1. Cosine squared over sine squared is cotangent. 1 over sine squared is cosecant. So you don't even, it helps some if you've got those memorized really well, but you can come up with those just from sine squared plus cosine squared equals 1. All right, so these are facts that we have to know, and we're going to use them in both solving equations and writing equivalent expressions. So I've just got, on the next slides, I've got several types of problems that you'll run into with this. We've got the function f is defined by x squared plus 1, and the function g is defined by 3x minus cosine squared x. What is the x coordinate of the point of intersection of f of x and g of x? I think there might be an issue. Right. I'm not 100% sure that x with that 3 is supposed to be there. We're going to see. Maybe I might have to take it out. Let's work the problem first. It feels like it's not supposed to be there, but maybe I'm just not working right in my head. So if I'm looking for points of intersection, they're really just asking you to solve an equation right here, right? So I'm going to say sine squared x plus 1 equals 3x minus cosine squared x. Actually, I think we're going to be okay. I don't think it matters that there's an x there. It's okay. So, this is different than the questions you were doing yesterday. The questions that you were doing yesterday and the day before, I never gave you a sine squared and a cosine squared in the same problem. Or if I did, it was already factored out for you, so you didn't have to think about it, right? So you never had a sine and a cosine in the same problem. So I'm going to run into a big roadblock if I try to like factor this, because I've got sine and cosine. So I can think of like 3 different ways to solve this right now, like off the top of my head. So that's what can be tricky, is that like you may solve it differently in a pretty different way than somebody else, and you could both be right there. So I'm going to do this 2 different ways that I can think of, so you can kind of see how this works. So one way that I can do this is I've got to be thinking of my trig identities. I've got to have them burned into my brain, and it just pops right up. And I know sine squared plus cosine squared equals 1. Currently, I do not have sine squared plus cosine squared. But what's going to happen if I take this cosine and I move it over here to the other side, right beside of that sine? It's going to have to be positive, right? So if I do that, I'm going to have sine squared x plus cosine squared x plus 1 equals 3x. And it was on the other page. It was our trig identity. We just learned that sine squared theta plus cosine squared theta equals 1. So what can I replace that expression with? 1. So now I've just got 1 plus 1 equals 3x. That went from really hard to really easy, right? So now I got 2 equals 3x. I divide by 3, and x equals 2/3. That would be my answer. So that is one way that you could solve the problem. Let me show you a different way, just so you can see what is out there. It is true, it is a fact. Well, let me change colors here. It is a fact that sine squared theta plus cosine squared theta equals 1. So, if I were to move, like I can rearrange this formula any way that I want, and it's still true, right? So, like if I were to subtract cosine squared theta from both sides, then sine squared theta would equal 1 minus cosine squared theta, right? This is still a fact. It's still true because I just rearranged my formula, right? So sine squared theta is 1 minus cosine squared theta. It's as good as an identity because it's just a rearrangement of that same function. So perhaps I don't recognize that I could move that cosine over here and change it to a sine. But I might think to myself, well, I need to have either all sines or all cosines. So since I know sine squared, so I've got sine squared x plus 1 equals 3x minus cosine squared x. Since I know sine squared x equals 1 minus cosine squared x, like this, I could replace my sine squared x with this 1 minus cosine squared x. They're equal to each other, so you could do that. And so now that I've got 2 cosine squared x's, I could try to combine those. So if I add cosine squared x here, it'll cancel, And if I add it over here, it also cancels, right? Leaving me with 1 plus 1 equals 3x. So 2 equals 3x, and I divide by 3, and I also get x equals 2/3 that way. So, and that's not my only option, because let's write this down too. You might want to like put a box around this. That's not my only option. I'm not going to do it, but it is also a fact that cosine squared theta equals 1 minus sine squared theta by similar reasoning, right? So instead, I could have changed my cosine squared to a 1 minus sine squared, and then it would have worked out that same way. Whenever I write that down, I picture Dwight Schrute saying that there. So, it'd be good if I had a video of him doing that. So for these, there can be lots of ways to solve the problems, which is what is frustrating to kids sometimes, because it's not like, here's what you got to do first. You got to try something, and if it doesn't work, you're going to try something else for those. But I think it's kind of cool, because there's like different logical ways of going through the same thing. That's what we're looking at. So sometimes they are not going to ask you to solve an equation. Sometimes they are just going to ask you to rewrite an equation in a certain way. So this is an example of something that they'll use on the AP exam. It's going to be on the free response question number 4 is where you're going to see something like this. And it's going to say, or possibly also multiple choice questions, but definitely free response question number 4. The function f is given by f of x equals cosecant x over secant x. Write the function f as an expression involving only tangent x and no other trig functions. So your answer can only involve tangent x. It could have other numbers. It could be like 2 times tangent x, or it could be 1 over tangent x, or it could be tangent x plus 7, but it can't have sines, cosines, anything like that there. But cosecant and secant don't have anything to do with tangent, really, right? Any ideas? What do you think we might could do here? What do you think, Connor? Okay, which one goes on top? Yes. So cosecant of x is 1 over sine of x. And then secant of x is 1 over cosine of x. Now, what should we do from there? Flip the second and multiply. Dividing fractions, it's easy as pie. Flip the second and multiply. So we got cosine x over 1. And so that is going to give us cosine x over sine x. Does that equal tangent? It does not. What does that equal? That is cotangent. But did they tell me to leave it in terms of cotangent? Even though it's like a cousin of tangent, you could almost think of it as tangent's cousin right here. It's not tangent, right? So then cotangent, how could it be written that involves tangent? 1 over tangent x. So 1 over tangent x is what they're looking for here. This one has fewer options for like how you could do it differently. Also, if they ask you to do something like this, you must show your work. You cannot just say f of x equals 1 over tangent x. You need to show your work, because your work is like your proof of the process. It proves that this is true. So whenever you're doing this, particularly on free response questions, on multiple choice, I guess you don't really have to show your work because they are only grading that for right or wrong. But on free response, show the work that leads up to this. So you need to show those steps leading up. Okay, questions? All right, here's another example of a type of question that they might give you. The function f is given by f of x equals secant squared x minus tangent x cotangent x. Which of the following is an equivalent expression for f of x? It's not calculator active, so you can't graph it and see if they match here. So I got to think of something that I can do here. Ideas. What do you think, Reese? Okay, I like that. Alright, so if I do secant squared x, I got tangent of x times 1 over tangent of x. And so that tangent right there is in the numerator. This tangent is the denominator. Those are going to cancel each other out. And I will get secant squared x minus 1. And at every point, you want to stop yourself and say, is that an answer choice? Is it an answer choice? It is not. It's pretty close to B, but I don't think I can just change the signs there. In fact, I would probably say this is probably going to rule out B as an answer choice, because those two are not going to be equal to each other. All right, ideas. You cannot move things to the other side only on these types of questions because it's not an equation. You are simplifying, your f of x is just telling you what this is, right? If you do move it to one side, you got to move it back so that it's equal to f of x. So it's not going to help there. Because like if you move these two things to the other side, you got to move f of x to the other side as well, which is going to make it negative f of x, which is just going to, like, you got to divide by negative 1 and flips it right back to what it is. So on this type of a question where they're asking for equivalent expressions, you do not want to try to move something to the other side. If it's an equation like we were dealing with on that first where you're like setting two things equal, then moving things back and forth is fine. That's a good question though. All right, ideas. What do you think, Reese? All right, so you are looking at, so let's think about that fact that you're thinking about there. Our fact is that tangent squared x plus 1 equals secant squared x. And I just gave you these to you, so you probably don't have that memorized yet, but it's on the other page, right? That was a Pythagorean identity. So, secant squared x equals tangent squared x plus 1, right? So it is acceptable here to take our secant squared x and turn it into tangent squared x plus 1. Right, so this secant squared x right here can equal tangent squared x plus 1. Now, if I've got tangent squared x plus 1 minus 1, what am I going to end up with? Tangent squared x, because that positive 1 and negative 1 are going to cancel each other out, and C is my answer. Yes? You could, because we could also work over here with our fact right here. So I could subtract that 1 from both sides, and it would still be a fact that tangent squared x equals secant squared x minus 1, in which case, if I'm doing it that way, I can just take secant squared x minus 1 and turn that whole thing into tangent, which still gets us that right answer. Yeah, so there's like a lot of different ways that you can do this. You could actually do it by changing secant to 1 over cosine and going about it that way. That is not the quickest way to do it. It will work eventually after a lot of pain and suffering, but it will not be like this. Have you done this before, Lewis? Have you seen it? Long had said they did a bunch of it when he was in Vietnam, so I wondered if you had seen it. So, questions? All right, let's keep going. All right, we got another rewriting problem. This one asks us to rewrite, and we can only have tangent, no other trig expressions, and we're starting off with a mess. We got a lot of stuff on this one. It looks kind of bad. So what do you guys think? Okay. We could. So it would be true that that is tangent squared x plus 1. This is definitely not the way I was thinking of going. So let's see what happens. Okay. Okay, so let's try that. So I got sine of x tangent squared x plus 1 over 1 over sine x. And then I would have to do dividing fractions easy as pie. So I got sine x times tangent. Oh, I think it's going to be beautiful. I love these because you get like a moment where it's like, oh, this is going to work. And it feels so. Oh, wait, is it going to work though? They're not going to cancel, are they? It may be. We're going to keep going. We're going to see. This is like, y'all don't even know. Y'all don't even know because you're kids. And you've never lived in a world where there wasn't GPS. But this is like whenever we used to live in Raleigh. Whenever when we were in school, we were in Raleigh, and then we lived there a year after we graduated too. And Raleigh is a big place, and they're always doing construction, and sometimes we would just make a wrong turn. And my husband, there was like a no turning back policy. He was just like finding a new way home. Like if we'd already turned, we weren't turning around and going back to the way we knew. We were just keeping on going, whether it was the easy way or not. It might take us 45 minutes to get home, but that's what he would do, because there was no GPS to type it back in, like to go back. So we're going to, sometimes I was like, just turn around. We knew where we were at. But he wouldn't. He was going to figure out a new way home. So we got this. All right, let's see. I don't know if it's going to work or not. We might have to eventually turn around. I know another way to do this problem. That's I felt like the signs were going to cancel and it was going to work, but they don't. Yeah. I'll write this back down so I can think. All right. The only way I'm really seeing it here is to go backwards from something we already had. Knowing what I know, because I know how to do these pretty well, yes, that's what I would do. But we can get there from here, and then I'll show you the way I would have done it that would have been a little bit quicker. We need to not go straight to tangent. I need that tangent squared x plus 1 to go back to what it was. Right? So if I change it back to secant, I got sine squared x times secant squared x. What can I change secant squared x to? Well, that's where I just came from, though. That's what I just had. Sine squared x times 1 over, are y'all seeing it? That's over 1. Multiply it together. Sine squared x over cosine squared x, which is tangent squared x. Finally, we have made it there. Now, we kind of went around the world to do that. If what I would have done differently, because we changed that to tangent squared x plus 1, but then we ended up needing to change it back. So sometimes you don't want to go straight to the function that they're telling you to use. A good strategy to use sometimes is to change things all to sines and cosines. So like if I did this, if I did sine x times 1 over cosine squared x, like that, over 1 over sine x, like this, then I could multiply those top two together and do dividing fractions, easy as pie, flip the second and multiply. So I'd have sine x over cosine squared x over sine x, I'm sorry, 1 over 1 over sine x, and I would flip the second and multiply, so I'd get sine x over cosine squared x times sine x over 1, which would give me sine squared x over cosine squared x, which would be tangent squared x. It's some of the same steps of what we were doing, but just a little quicker to get there for that. Which is what I think is so cool, and also what makes some kids want to pull their hair out, because it's not like every problem's different. Like, it's not like I can say you always want to turn everything to sine and cosine. It's not always the best route. It's not always the quickest. But the good news about this is that as long as everything you do is mathematically correct, even if you do this long way, like you get lost on the beltway and you just keep on driving, right? As long as you end up to the right destination and do not break any laws along the way, you get it, right? Even if your way is not the easiest way, even if it's the harder way. So it's okay for that. In fact, I felt good about that tangent squared x plus 1 there for a minute, because I was thinking, oh, this will work. But if we had canceled signs, which you can't do, you'll get tangent squared x plus 1. Not correct for this. It's wrong. So you can, don't take this. This is not like you can do anything you want. There is a correct answer, and there's certain ways you can get there, but like you can't go on the wrong way on the street to get there. Like, you got to follow the rules. You can get a wrong answer on this for this. So it's not like one of my favorite. And is it Grown Ups or Grown Ups 2, where the little boy at the beginning is practicing his math problems? Y'all probably don't even pay attention to that part like I did, but he's practicing his math problems, and they're like, what's 2 times 7? And he's like, 27 or something like that. And his mom's like telling him, good job, and saying, we don't want to destroy his confidence. This is not like that. You cannot. And I was like, oh gosh, what is happening? This is for real. Some places. All right, so example 5. This one's an equation. So we are using an equation, but we've got cosine and tangent, and it's equal to -1. So we're going to have to use some trig identities here. ideas. What can we do? You can do this, but that would be a wrong turn. I mean, I'm not saying you couldn't get there, but you drive around for a while before you got there. There's a much easier way. You're doing like I've done before and circling all the way around the beltway to get back to the point you need to be to. So, all right. Any other ideas? Yeah. Yeah, that's like the Parkway version of what you could do. All right, what do you think? Any ideas? It's a pretty quick one, actually. No, that's what he said. I mean, you can. You can do it. Yeah. Uh-huh. Beautiful. Look at this shortcut right here. This is sine x over cosine x equals -1. What is going to happen? The cosines cancel. Now what have we got? Sine x equals -1. That's like yesterday. That's like the easy ones the other day, right? So where does sine x equal -1? 3 pi over 2. It's your y coordinate. And so there's your answer. Yeah. So yes, we could have divided by cosine, but then we would have gotten secant. You'd have to move a secant, you'd have to move the secant over. You'd have to change it. What you'd probably end up having to do is almost going like back to where you started and then finishing this way. So this would be by far the quickest way to do this problem. Here. So sometimes it's just like one little step that you got to do. Sometimes it's more. All right, let's look at this one. This one almost looks like the problems we've already done. I've got cosine squared x minus cosine x plus 1, which we did like some factoring on. It almost looks like what we did before, but it's not equal to 0. It's equal to sine squared x here. So I can't do this problem with a sine squared and a cosine squared, right? What do you think, Molly? It would work if that cosine right there was squared, but it's not. So an important thing for Pythagorean identities is they only work if they're squared. So like sine plus cosine does not equal 1. It's got to be sine squared x plus cosine squared x. And if I move the cosine squared over, it's got to be negative. So I'll have sine squared x minus cosine squared x, which is not going to be the same. There's not a cosecant in this one. It's cosine. Yeah. What do you think, Molly? Almost. So I see what you're saying here. So I would do it a little bit differently. It is a fact. Let's put down our fact again, right here. Fact. Sine squared x plus cosine squared x equals 1. So if I am wanting to, if I subtract this 1 over here, I'll get sine squared x minus 1. So in this case, if I move something, if I subtract my sine squared x, I've got cosine squared x equals 1 minus sine squared x. It's not quite the same as sine squared x minus 1. So if you do it, you would have to multiply through by a negative that way. what I would do instead is, it is a fact that cosine squared x equals 1 minus sine squared x. It is also a fact, if I do by similar reasoning, that sine squared x equals 1 minus cosine squared x. So on these types of problems, if I have sine squareds and cosine squareds, I'm going to use one of these two to replace it, so I've got all sines or all cosines. What should I pick? Should I make everything sines or everything cosines? Or does it matter? What? That's the big thing right there. That cosine x cannot be replaced because it's not squared. And Pythagorean identities only work whenever it's squared. So you want to change everything to cosines. So what I would do right here is I would just take that sine squared x and change it to 1 minus cosine squared x. So we got cosine squared x minus cosine x plus 1 equals 1 minus cosine squared x, like this. Now, it would be okay, Molly, if you would like move that 1 over. You could replace it with negative cosine squared x. You'll end up with the same, like you get the same answer if you do it that way. So for this, I probably just need to like move everything to one side, because I've got squares here. So if I subtract this one right here, that's just going to cancel on both sides. I'm going to add my cosine squared x. So I got 2 cosine squared x minus cosine x equals 0. And this is what we were doing the other day, right? What do I need to do? Factor, and how do I factor that one?
But if you're adding the cosine x, I thought it was negative. So like, would that cancel or no?
It is a negative over here, so you have to add it to the other side. Both of these are positive, so you'll get, so you got to change its sign when you move it over. Yep. Perfect. Okay, now they're equal to 0, so we can just set each one equal to 0. We got cosine x equals 0, and we got 2 cosine x minus 1 equals 0. Over here, we're going to have to solve that, so we'll get 2 cosine x equals 1, so cosine x equals 1/2. And we just need to find the places on the unit circle where this happens. So cosine of x, where does it equal 0? Pi over 2 and 3 pi over 2. So there's 2 of our answers. Where does cosine equal 1/2? Pi over 3 and 5 pi over 3. Are y'all starting to get the unit circle in your head? Like, you can see it there. Charlie the other day he was like closing his eyes, and like he was like a genius calculating there. So if you're not, it'll help if you don't look at your actual unit circle. And sometimes I get it mixed up in my head, and I just got to like draw it out. So no shame in that too. All right. So that's everything that we got here.